All right, reasonable domain and range. So let's talk about some tips about reasonable domain and range, okay? The first thing you want to decide when you're reading a word problem is my domain and range going to be discrete or is it going to be continuous, okay? So a nice rule of thumb is if I'm dealing with liquid, temperature, height, anything like that, right, it's going to be continuous, okay? If I have a temperature, like if I'm at 50 degrees and I'm trying to get to 90, I can't jump there, right? I'm going to have to gradually get there, or I'm going to shoot up and heat up really quickly, but I'm going to get there, but I've got to go through all those other temperatures, okay? Now, if I'm trying to sell seats at a movie theater, or tickets, or in this case, we have cheerleaders selling blankets, nobody's going to buy half a blanket from me, right? I mean, they want a full blanket. So you have to kind of think about like what they're selling and how it's being sold, okay? So when we look at problem number 6 and we're looking at A, if the cheerleaders are selling blankets, would that be continuous or discrete? Okay, so we know this one's going to be discrete. If we look at a storage tank and we have liquid, right, just like if I'm trying to pour liquid into a cup, like milk into a cup or water or whatever, if I'm trying to get it out, a storage tank holds 500 gallons of water and it drains at a rate of 2 gallons per minute. Would that be discrete or continuous? Continuous. It's liquid leaving it, right? I'm not taking like lumps out at a time. I'm opening a valve and I'm letting it drain out. So it's going to be continuous, right? So this would be continuous. If I have a scuba diver, which this one's a little kind of, you got to listen to this one, right? It says a scuba diver descends to 105 feet, okay? They're not telling me a rate, he just gets there, okay? But now they're telling me, hey, she wants to ascend, which means she wants to come back up, and she's going to come back up at this rate of 7.5 feet per minute, okay? So is this going to be continuous or discrete? Continuous also, right? And then the last one, again, we have a temperature of a pool at 8 a.m. is 72 degrees. The temperature increases at a constant rate of 1 degree Fahrenheit every hour until 5 p.m. So what do you guys think? Would that be discrete or continuous? Constant, right? So it's continuous. It's going to keep right. If I'm at 72 degrees and I'm trying to increase the temperature, I've got to go through all the other temperatures to get to my last one, right? So this one is also going to be continuous, okay? Okay. Now, let's go through and actually get our domain and range. It has to be reasonable. It has to match, okay? So for problem, the very first one, if we think about them selling the blankets, what is the domain in this case? What's driving it? Is it the number of blankets or is it the money I'm making? Okay, so in this case, it's going to be the number of blankets. And it's actually the number of blankets sold, right? And then the range is going to be the money earned. Okay, so if I'm a really horrible salesman, how many blankets can I sell? 2, like none, right? So 0 if I'm really bad. If I could sell 1 or 2, and then remember, you guys can do the ... and then what's the most blankets I can sell? 75, okay? Now let's do the same thing for the money. If I'm a really bad salesman, how much money can I make? $0, right? Then maybe if I sold 1, I can get 50. If I'm a really good salesman, how much can I make? 3,000, right? So 50 times 75 is 3,000 what? 750? Okay. So there we go. And I've got my cool little brackets on the end here if I can make them better. But that's going to be my discrete domain and range for this, okay? Now, problem B. Now we need to kind of look at this one, okay? We had one very similar to this at the beginning of the school year, okay? When we look at this, if I have a storage tank that holds 500 gallons of water and it drains at a rate of 2 gallons per minute, remember we talked about anytime you get a rate, they're telling you your domain and range right off, okay? So my denominator, my per minute, gallons per minute, the minute piece is my domain. So this is going to be time, and it's going to be measured in minutes. My range is going to be water, or volume maybe, if you want to look at it like that, and it's going to be measured in gallons, okay? So if I'm trying to go through and drain this tank, and I'm starting out at time, what time do I start at? Time. What time am I going to start at? I'm going to start when? When would I start? I got to start at 0, right? Okay, so we're going to start at 0, less than or equal to my variable, my domain is X. Now, how many minutes is it going to take me to drain these 500 gallons? 250, right? It's the 500 gallons divided by 2, which gets me the 250 minutes, okay? Now, if we're talking about gallons, how many gallons? If I'm at 0 minutes, how many gallons have I gotten rid of?
0.
I know, but I haven't got rid of anything yet, though, right? We're talking about how many things. So we've gotten rid of 0 gallons, less than or equal to Y. Once I reach my 250 minutes, how many gallons have I gotten rid of? All 500, right? It's all gone, okay? Now, we good? All right, problem C. We have the scuba diver, okay? Again, this one's a little different, right? Because they're going down to 105 feet all the way down, and now we're talking about them coming back up, okay? So in this, we're talking about feet per minute, so we know that the domain is going to be our time, and we're going to measure that in minutes, and then the range is just going to be my depth, or, my feet, okay? So if I'm talking about the time, what time do I normally start at? We're going to start at 0, right? Less than or equal X, less than or equal. How long is it going to take me to get from that 150 feet below, right? It's going to take me 14 minutes to get back up to the top, right? Do you guys know how we got the 14? Right, you're going to take the 105, you're going to divide it by 7.5, and you're going to end up with 14 minutes, okay? So it's going to take us 14 minutes to get to the top. Now, here's the piece we have to be a little bit careful with, okay? The scuba diver is down to 105 feet. So where are they starting at? Negative 105. They're starting out at negative 105. They're below sea level, right? So that's going to be less than or equal to Y, less than or equal to, where are they trying to get to?
0.
To 0, okay? All right, problem D. Now we have the temperature in a swimming pool at 8 a.m. was 72 degrees. So I'm going to make a little chart over here to help me. So 8 a.m., the temperature was 72 degrees, okay? Now it says the temperature increases at a constant rate of 1 degree Fahrenheit per hour until 5 p.m. So I already know my domain, based on the rate they're giving me, is time in hours. And then the range is going to be the temperature, right? The temp in Fahrenheit. Okay? So if I'm looking at this, I know I'm starting at 8 a.m., but I'm measuring everything in hours. So what hour am I starting at? We're starting out at 0, right? So at 0, less than or equal to X. Let's drop down to our range. If I'm at 0 hours, what's the temperature? 72, right? And then how many hours does it take me to get from 8 a.m. until 5 p.m.? 9 hours, right? And if I've gone 9 hours and I raise 1 degree per minute, what's my final temperature? 81 degrees, okay? All right, so there will be about 3 problems like this, 4 problems on the test, guys.